Hello again. This is Mrs. Marshall, and I'm here to teach you about Unit 2, Day 3, complex numbers. So, to begin, a complex number is an expression of the form a plus b I. Now, the question is, what is a? A is, let's get, what is a there? All right, here we go. A is the real number. Let's put my R back. And b is the imaginary number. The bi part is the imaginary number part. And the question now is, where do you get imaginary numbers from? Remember, I equals negative square root of 1. And so if I were to solve this thing out and solve for negative 1, and we get I equals square root of negative 1, and then I would solve for negative 1 and square it. So I squared would equal negative 1. That just gives me another format. So in other words, sometimes you'll have a single I, so I to the first power, but sometimes you'll get an I squared, which takes it back to a real number value. So we really want to remember and know that I equals square root of negative 1 and I squared equals negative 1. And where did we get that from again? It's because I solved for negative 1. First example, we want to write each as a complex number. So, example 1, we have square root of negative 16. Okay, so square root of negative 16, if you think about it, that is the same thing as the square root of 16 times negative 1. If I just break it apart and take the negative part out, or away from the 16, because the negative part is what makes us have an I. And then we solve them literally separately. So we have the square root of 16 times the square root of negative 1. And you already know what the square root of 16 is. The square root of 16 is 4. And the square root of negative 1, that part is I. So again, square root of 16 equal to 4. And the square root of negative 1 equaled I. All right. For our second example, we have 5 plus the square root of negative 12. So we want to simplify this again. 5 plus, this time, what times what is negative 12? Well, for the first one, square root of 16, that was a perfect square number. When we take the square root, we want to take square roots of perfect square numbers. So we think of a perfect square factor pair. Well, 1 and 12, not it. 2 and 6, not it. Neither one of those are a perfect square. 3 and 4. 3 and 4 are it. But don't forget, we have that negative 1 that we have to multiply separately. So I'm going to rewrite it 4 times 3 times negative 1. And then technically, that is the same thing as 5 plus square root of 4 separately times square root of 3 separately times the square root of negative 1 separately. And now we can write our final answer. Nothing is happening with the 5 at all, except for it's just coming on down. So 5 plus the square root of 4 is 2. And the square root of 3, well, there's nothing that can happen with the 3. Let's change that to green. There's nothing that can happen to the 3, so we just leave that as the square root of 3. And square root of negative 1 is I. So square root of negative 1 converts to I. Now, some of your teachers might want you to write your answer with the I in front, but just know that for the first one, this answer is just 4I. And for the second one, the answer is 5 plus 2 square roots of 3I, or 5 plus 2I square root of 3. And the purpose of putting the I in the front would be to make sure that the square root of 3 is not too long to make it seem like I is under the square root as well. Operations using complex numbers. So, first thing to do or know is that you're going to combine quote unquote like terms. The real with the real, imaginary with the imaginary. It's sort of like real recognize real, fake recognize fake. Okay, got a little hood there. But real with real, fake with fake, or rather imaginary with imaginary. So our first example, we are going to simplify each expression. Here's our first expression, and we are going to be adding. So with complex numbers, you can add. So let's add the real with the real and the fake with the fake, or rather the real with the real and the imaginary with the imaginary. So 3, well, let's go ahead and rewrite it outside of the parentheses first. 3 plus 5i plus 4 minus 2i. Since there's a positive in the middle, the signs of these remain the same. They stay the same. So now let us combine like terms. Well, let's highlight them. 3 and the positive 4, those are the real numbers. So 3 plus 4, y'all know what 3 plus 4 is. That's 7. And then positive 5i minus 2i, well, that is plus 3i. And this is our final answer. Ta-da! We have added complex numbers. Now let's subtract them. So this time, this is going to be 3 plus 5i minus 4 plus 2i, because the signs of these do change. And some of your teachers write your loops on top. So either way, it's just I didn't have room on the other one to write them on top. -4 times, or -1 times 4 is -4. And -1 times -2i is positive 2i. And now we just combine like terms. Real with real, 3 minus 4, so that's -1. And then fake plus fake, or rather imaginary plus imaginary. And so 5 plus 2i is plus 7i. And that is your final answer. Now the question is, can you just add and subtract? Absolutely not. We got multiplying. Let's multiply these things. And there are technically 2 ways you can multiply. I'm going to show you both ways. It's whichever way that you decide that you want to multiply. It's up to you. So a lot of you might have grown up in the FOIL era. And so that means you're going to do first, outer, inner, last. And we think of it like this. The first numbers, 3 and 4, multiply, and that's 12. FOIL. So, the outer numbers, 3 and -2, you multiply those. It's perfectly fine. They don't have to be like terms to combine, to multiply them. Just like when you multiply, something like 2x squared plus 3, and then you have a 4 out there. Well, 4 and the 3 are like terms, but the 4 and the 2x squared are not. But you can still combine those. So it's the same type of situation. And so we have, that is -6i. And then we want FOIL. It's FOI. So let me just put this up here. Way number 1. And we're going to put FOIL. Boop, boop, boop. So it stands for first, outer, inner, last. So we are foiling the first part first. And then we have the outer. And now we want the inner. So the inside is plus 20i. That's our inside. And our last. These two together. 5i times -2i is -10i squared. It is to the second power. It is to the second power. So now the thing is, we need to make sure we remember what I to the second power is as we combine like terms. So step 1, this -10i squared is the same thing as -10 times, well, what is I squared? -1. Because remember, I squared equals -1. So you can't forget that. And so -10 times -1 actually equals a positive 10. And so instead of putting -10i squared, we're going to put positive 10. So I'm going to rewrite my whole line. 12 minus 6i plus 20i plus 10. And now we can combine like terms. Real with real, imaginary with imaginary. And that is 22. And then imaginary with imaginary. And that is 14. And that is our final answer. What in the world is that? Step 1, though, is you need to simplify first. And so the square root of 12 simplifies to be, well, let's see what that simplifies to be, which is right here, 2 square roots of 3. And that's what your special handy-dandy calculator that we suggested you purchase will do for you. If you put square root of 12 in that calculator and press enter, it will simplify that bad boy, and 2 square roots of 3, just like it is, will pop up. So So I suggest if you haven't got that calculator, you should get that calculator, especially for this unit. And we will use it for units moving forward. Square root of 3i, that simplifies to be, square root of, or negative square root of negative 3. Oh, fix that. Simplifies to be square root of 3i. 3 doesn't simplify at all. It stays old, regular old 3. And the square root of negative 4 simplifies to be 2i. So simplify it first. And then after you simplify, then we're going to do the regular old box method to multiply. So this is the 2 square roots of 3 minus square root of 3i. Just make sure your I is not under the radical if you put it in the back, or you can put it in the front. And then we have 3 plus 2i. And now let's multiply. All right. 2 times 3, or 2 square roots of 3 times 3. You can only multiply the outside numbers. So that is 6 square roots of 3. And then 2 square roots of 3 times 2i. Well, again, you only multiply the outside numbers. So that is 4 square roots of 3i. And negative square root of 3 times 3, and that's I, of course, is negative 3 square roots of 3i. And let me put my plus sign for my 4 so that I know what sign to put when I write it as a polynomial. And negative 3 square roots of 3i times 2i is negative 2 square roots of 3i squared. But I have that I squared there, so again, I need to cross that out and figure out what that actually is. So negative 2 square roots of 3 times, the I means negative 1. So this technically is 2 square roots of 3 positive, because a negative 2 times a negative 1 is a positive 2 square roots of 3. And now we can write our final answer, sort of. Rewriting it in a straight line, 6 square roots of 3 plus 4 square roots of 3i minus 3 square roots of 3i plus 2 square roots of 3. Why? Because that's where that comes from. And now let's combine real with real, imaginary with imaginary. So our real numbers are 6 square roots of 3 and 2 square roots of 3. So that is 8 square roots of 3. And then our imaginary numbers are 4 square roots of 3i minus 3 square roots of 3i. And so that leaves you with 1 square root of 3i. But we don't put ones. We're just going to leave it just like that. And there's our final answer. All right. There's one final operation with complex numbers that we need to know, and that is exponents. So first thing you want to do with exponents is get I in terms of I squared first. So whatever the power is, you need to figure out how to make that power something where you times them by 2 so that you can have a I squared so that it'll turn into a negative 1, essentially. All right, so step 1, let's get this I to the 23 with a 2 in it. And only multiplying can happen, or technically when you are multiplying or adding, when you have multiple exponents, so I to the 23rd, only addition occurs when you're multiplying. So it sounded weird. I to the 23rd equals I to the 22, because we want to get something that's a factor of 2 or a multiple of 2 times I to the 1. And I always go with my I guess closest multiple of 2 to the number we're talking about. We're talking about 23. So the closest number to multiple of 2 to 23 is 22. If I had 25, my closest multiple would be 24. So it's always the one less. If I had 17, my closest multiple would be 16. So it's always one down, one less. And I have I to the 22 times I to the first. Now, the thing here is the I to the 22. That part can be rewritten. So I'm going to put parentheses around it as I Well, now you want to think about multiplying. Why is 22 a multiple of 2? Oh, because it's 2 times 11. And now I squared is singled out and it's in parentheses, and we can actually turn that into a negative 1. But before we turn it to a negative 1, I'm going to keep writing this. And so now let's turn it to a negative 1, because I squared is the same thing as negative 1. And then to the 11th times I to the 1st. All right. Now the thing is, what is negative 1 to the 11th power? Well, it's odd. So negative 1 multiplied to itself an odd amount of times will keep it as a negative 1. And I to the 1st power is I. But then negative 1 times I is just negative I. And that's our final answer. Let's do another one. I to the 11th. All right, we want to think a multiple of 2. Our first multiple of 2 is 10. That's the closest one to 11. And now we want to rewrite I to the 10 so that that's technically I to the 2nd times whatever number multiplies to get 10. And that's 5 times I to the 1st. And look at there. There's that I squared. And so I squared is the same as negative 1 to the 5th, I to the 1st. And so negative 1 to the odd power, again, is negative 1 times I. I'm going to put my times up there. And negative 1 times I is negative 1. Rationalizing complex numbers. All right, so step 1, when you have a complex number and it's in the denominator, which looks like that, you have to rationalize. It must rationalize. And the reason why is because no complex numbers in the denominator are allowed. You cannot have imaginary numbers in the denominator. It's sort of like dividing by 0. You can't do that. So you can't divide by an imaginary number either. You cannot do that. So it cannot be in the denominator. So what you are going to do is multiply by the complex conjugate, whatever that means, to rationalize denominators only. And it's just for the denominator part. You do not have to rationalize if your complex number is on the numerator. It has to be on the denominator. So what is a complex number again? Z equals A plus BI. And now what's a complex conjugate? Complex conjugate is denoted with this symbol with the line over top of the Z, and is the opposite. So if the complex number is plus BI, well, the complex conjugate is literally just the same, but it's minus. That's it. That's literally it. And so when you multiply by a complex conjugate, you're multiplying Z, which is your complex number, times your complex conjugate. Let's delete that. And Z times your complex conjugate. So here's my Z. Times the complex conjugate is just those two. The A plus BI and the A minus BI kind of reminds you of difference of squares. And there's your answer. Instead of it being a difference of squares, it's actually a sum of squares. And that is the shortcut to multiplying these. Instead of doing the box, you can just shortcut multiply by doing A squared plus the B squared. And the I, notice the I is gone. There is no I. So let's do our examples. Examples, rationalize the expression. Okay, so step 1, there is a I in the denominator, and that means no complex number in denominator allowed. So this is like ding, 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 red flag. I need to multiply. I need to get that bad boy out of there. Now the question is, what do you multiply by? The complex conjugate. So the complex conjugate of this is times, okay, that's a positive 4i, so the complex conjugate is negative 4i. Same thing here. Whatever you do to the bottom, you do to the top. So negative 4i times it on the bottom and negative 4i times it on the top. And again, why? Because the conjugate is negative 4i. And now you distribute like you normally would. You're going to distribute negative 4 times the 3i and negative 4i times the 7, and then negative 4i times 4i. And we have to figure out what those are. So it's literally distributing. Negative 4i times 7 is negative 28i. It's like I is representing an x. It's x in this equation. It's the letter I instead. So then negative 4i times 3i is negative 12i squared. Look at that I squared. So it looks like that I is going to go away. But before we make it go away, let's finish the bottom. That is negative 16i squared. Looks like that's going away as well. Okay, negative 28i minus 12 times negative 1, because we know that I squared is the same as negative 1, divided by negative 16 times negative 1, because I squared is negative 1. Okay, next thing is we need to simplify. Negative 28i plus 12 all over positive 16. And then the last step, we're almost there, is to simplify. What can divide all three of these numbers? All three of these numbers can be divided by 4. So 16 divided by 4 is 4. 12 divided by 4 is 3. Negative 28 divided by 4 is negative 7. And so our final answer, well, I guess this is just not the final, but it's just the final because we're going to rewrite it one more time, is negative 7i plus 3 divided by 4. But the thing is, we usually like to keep it in the form a plus bi. So the number that's the real number, we usually put first. That's your standard form. And our imaginary number goes in the back. So since our imaginary number is negative 7, we want to put minus 7i in the back, divided by 4. So we're just going to move that to the back. And this is now our final answer. If you put the imaginary number in front and the real in the back, is it wrong? No, it's not wrong, but it's just not in standard form. So you need to make sure you put it in standard form where the real is in the front and the imaginary is in the back. Let's do one more of these. 3 plus 5i minus, or divided by 1 minus 2i. All right, so again, that denominator. You cannot have that denominator there. So we're going to multiply by the conjugate, and that is 1 plus 2i. Whatever you do to the bottom, do to the top. And yes, we're going to have to FOIL and do all of that. So I'm going to put this stuff right here in parentheses. And when I say FOIL, we're actually going to use the box. We're going to use the box. But for the bottom part, we are going to use the shortcut. Use shortcut. And so what did the shortcut say? A squared plus B squared. That is the shortcut. So for the top, and I'm going to do it in two parts, 3 plus 5i, and this is 1 plus 2i. Again, I'm going to put my plus closer to my 2i so it can be two separate terms. And then I'm going to multiply. All right, so multiplying this is 3 times 1, which is 3. 3 times 2i, which is positive 6i. 5i times 1 is positive 5i. And 5i times 2i is plus 10i squared. But remember, this right here is going to be 10 times negative 1, which equals negative 10. And our numerator is now going to be 3 plus 6i plus 5i minus 10. If I simplify that, that is, well, let's real with real. So that is 3 and negative 10, which is negative 7, plus the imaginary with imaginary, 6i and 5i, so that is plus 11i. And that is the top. So we're not quite done, but this is the top, or the numerator. Top is just a shorter word to write. And now we want the bottom. So the bottom part of this is 1 minus 2i times 1 plus 2i. You can do the box again. It's going to get you the same answer, but I'm just going to do the shortcut. So my shortcut is a squared, and my a squared, let's use different colors. A squared is 1, which is 1 squared. And then my b squared, let's use purple. My b squared is the same b that's in the first set of parentheses, because we're just taking b and squaring it. So it doesn't matter what the sign is. My b squared, and my b squared is 2 squared. And then in the middle, you're going to add. So 1 squared plus 2 squared is 1 plus 4, which equals 5. And so this is the bottom. And so my final answer, so we have the top, and then you have the bottom. Let's see if I can write bottom sideways. Is -7 plus 11i all over 5. Ta-da! And that's our final answer. All right. Last step, last thing is quadratics. Solving quadratics with complex numbers. So this would come from when you have square root and you have a negative under it. Well, where do you get square roots from in quadratics? The quadratic formula. So let's do some examples. Find the complex zeros for each. So sometimes you have to use the quadratic formula, but another time in which you got to use the square roots is when you are just simply solving for x squared, and you're not having to do trinomials where you factor with headphones or big X, however you factor. You're not having to do grouping or GCF. You just have to simply solve for x squared, move one number to the other side, and solve. So like this example, that's what this is doing. We want to solve for x. There is no factoring. There is no GCF. There's nothing except for just getting x by itself. So x squared, let's subtract 12 to both sides. That's gone. So this is x squared equals -12. And now we want to get rid of the square. Well, the way you get rid of the square is doing the square root. So this is x, and that's gone, equals the square root of, oh gosh, -12 all over again. Square root of -12. But then think, what times what is -12? Because we want to think of a perfect square factor pair. And our perfect square factor pair is 4 times 3 times -1. Square root of 4 times the square root of 3 times the square root of -1. That leads you to the answer of x equals, and don't forget, side note, when you take the square root, it automatically follows with plus or minus, plus or minus, plus or minus. So your final answer is going to be plus or minus. The square root of 4 is 2. This is literally what we did earlier. The square root of 3, well, that's just going to be square root of 3. And then the square root of -1. Well, y'all know what square root of -1 is. It's I. So now we have an I. So without all of the colors, x equals plus or minus 2 square roots of 3 I. Just make sure your square root is not on top of the I. Let's solve it. Now this one, you probably could use the trinomials factoring headphones, but then you think 4 times 37, like what is that? If you have no idea and you don't have a calculator, you need to do the quadratic formula. Solve with quadratic formula. And so now we need to figure out what the A, B, and C are. So A is 4. You know that. That's A. B is -24. The sign has to attach. And C is 37. And now what is the quadratic formula? Me. opposite b. And I like to say opposite because negative b means, like, some people get confused and be like, oh, it's already negative, so it's negative b. No, it's the opposite. It's a negative b, so it's opposite. So opposite b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. I wanted to be Beyonce. I told my students that, but Beyonce became Beyonce, and yeah, so I'm me now. Anyways, hope you enjoyed that. Now let's fill these in. So we want the opposite of b, and so the opposite of b is positive 24 plus or minus square root, make that thing kind of long. Okay, square root of b squared, which is negative 24 squared, minus 4a, which is 4, c, which is 37, all over 2a. And now we solve it. So this is 24 plus or minus, and then you got the square root of something in there. Well, if you have your handy dandy calculator, it's negative 16 all over 8. So what in the world? We're going to end up with a complex conjugate. So let's take the square root of negative 16, 24 plus or minus. Well, you already know what the square root of negative 16 is. It is 4i because of that negative. And then 8. And then we need to simplify. Well, what can all of these be divided by? All these can be divided by 4. So 8 divided by 4 is 2. 4 divided by 4 is 1. It disappears. And then 24 divided by 4 is 6. Okay, almost there. 24, okay, let's go ahead and rewrite that as 6 plus or minus I over 2. So that's technically your answer, but if we're writing it in the form a plus or minus bi, technically a plus bi, which is what I gave you, but it's plus or minus, we need to separate them. So we need the a value and we need the b value. So now the last step is to write as a plus bi. So you need 2 separate values. So let's go ahead and separate this. I'm going to keep it in red. So let's separate it. 6 over 2 plus or minus I over 2. Now the question is, we want b. Like, what in the world is b? Well, there's an understood 1 right there. And it was a 1 from when it was a 1 at the top. There's your 1. And so now our final answer is going to be, well, 6 over 2 is 3 plus or minus, and our b is 1/2 I. And that is our final answer. All right, I hope you enjoyed this video. You will practice more of it in class, of course, and I will see you next video. Marshall out.